I hope you know the question is readable. Please respond once and we'll get started. I hope the question is readable. The
Yes.
ratio of number of atoms present in a simple cubic, body-centered cubic, and face-centered cubic structures are respectively. Go ahead. What's your answer?
B.
Naturally simple cubic 1, body-centered cubic 2, face-centered cubic 4. Z effective जिसको बोलते हैं Z effective. Do you need any help in this? Simple cubic में naturally it's 8 corners. Body-centered cubic में it's 8 corners plus 1 body center. And face-centered cubic में it's going to be 8 corners plus 6 faces. Face-centered cubic का ये जो स्ट्रक्चर है ना सीसीपी होता है सीसीपी 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 एचसीपी ये दोनों में ही एफसीसी होता है सीसीपी एचसीपी दोनों में एफसीसी होता है तो फेस सेंटर्ड क्यूबिक का या कभी कभी सीसीपी एचसीपी बोले विल टॉक मोर अबाउट इट इन ड्यू कोर्स आई थिंक दिस इज अंडरस्टूड विल वांट टू मूव टू क्वेश्चन 2 sodium metal crystallizing in a BCC with unit cell edge length of 4 angstrom. The radius is, you want to find the radius. You want to find the radius.
17.
17 is what I got. 17 is what I got. That's, I hope you can hear me loud and clear. You'll want to respond.
Yes.
Question 2. Question 2. Now, right away, when it's a BCC, and about the radii, in BCC, body-centered cubic, it's the body diagonal which is in contact. So 4r is equal to root 3a. I think this is the result we'll want to have. R would be root 3a by 4. And naturally, a given being 4, it will be a simple calculation root 3, which is almost 1.732. Could be written as 17 as an integer into 10 to the power minus 1. So that's the basic answer which I need here. The nearest integer is 17. I hope I'm being understood. Question 2, 17 is the right answer. This is for BCC. Naturally, for simple cubic, the relationship is 2r is equal to a. And for face-centered cubic, the relationship is 4r is equal to root 2a. I hope these results are there at the back of your mind. We'll want to move on. I want somebody to approve and, we'll want to move to the next question. Question 3. Question 3. Yes, we can move on. Please respond. So it's a mixed bag. All the questions are of the same type and are equally simple. But some of them, would call for some steep calculation. I end up presenting all questions to you. And it's about getting used to the very simple basic routine questions first, which is naturally about packing fraction, coordination number, radii calculation, and density calculation. Now in density, I must have made it very clear. Density is equal to Z effective into, the atomic mass, which I prefer writing M as the molar mass of one atom. Now upon A cube and Avogadro number. So I must have told you this particular ratio is the mass per atom into the effective in mass of the unit cell, and A cube is the volume of the unit cell. So this is going to be effective with the density. Now, molar mass is given, cubic crystal structure A is given, number of atoms present in a 1 unit cell of A is. So they're looking for Z. See if you are understanding the question in the very first place, and please tell me if you have an answer. Yes, please. I want to hear from someone. Density is 3. I think this was not that challenging. The effective has to be calculated. Molar mass is 12. 4 aega. So this 6.02 into 10 to the power 23 are given in the problem. And I've always told you, 300 picometers should be taken as 3 angstrom. The advantage we have with angstrom is angstrom being 10 to the power minus 8, 10 to the power minus 8 centimeter. Density is always going to be in CGS unit. So the cube of this, I told you in the past, will go a long way in evening out 10 to the power 20C. So this is eventually going to be, 10 to the power minus 24, which will even out 10 to the power 23 to a very large extent. And if you do it diligently, you'll get Z almost equal to 4. And if Z is equal to 4, what kind of a crystal is it?
FCC.
Certainly, it's an FCC. You can take a screenshot, else I'm recording the video as well. I want it to be done in less than an hour because I have to, prepare another. Actually, it's prepared, but I have to pass on another problem sheet on solid state to you. There's a cricket match at hand as well. So far, so good, I believe. Question 3, we move to question 4. Question 4. Again, a routine problem. Again, it's about getting used to.
Sir, option C.
Option C looks good. Option C looks good. I think you're all understanding me. Option C looks good. For a FCC, 4R is equal to root 3A. So sorry. For R is equal to root 2A. And for a BCC, 4R is equal to root 3A. So 4R is equal to root 2A could also be written as A is equal to 4R by root 2, which is nothing but 2 by root 2R. And 4R is equal to root 3A. Simple as a clocks. We'll want to move on. Question 5. Now, these are real J problems and outright scoring. Question 5. 5 is a nice little problem.
फिर 4 है.
Again, Rityasa is spot on as usual. You want the densities in FCC to BCC, and any day, playing along the equation, rho is equal to Z effective into the molar mass of 1 mole of atoms upon Avogadro number and A cube. Hey, realize what's only going to change for the same metal having the same molecular mass. So I reckon this is understood. This is going to be the constant. This is going to be remaining the same. Naturally, I'll take the 2 unit edge lengths. The A would be different. FCC or BCC may, the effective will be different. And yet again, NA would remain the same. So when it comes to the density FCC versus density BCC, it will be Z effective FCC upon Z effective BCC. And, I'll take the A of BCC, which is again a value given upon A of FCC and cube of this. So 4 by 2, and here I'll get BCC के लिए 2.5 upon FCC के लिए 2 is given. I think I'm being understood. And if you again do it properly, I think I'm going all right. This ratio is going to be 4. 4 is the right answer. So if you do it diligently, I think this is exactly how Rityasa would have done, and the rest of you would want to respond as well. We'll want to move on. 4 is the right answer. So far, so good, I believe. Moving on. So you have an iron oxide crystallizing in a cubic lattice with a unit cell length of 5 angstrom. Density is given, A is given, a rho is given, number of FU units present per unit cell is. So yet again, we have a problem of finding Z effective. By the language of the question, I realized Z effective needs to be calculated. And yet again, we'll want to go with the usual formula, which is rho is equal to Z effective, which has to be calculated. The molar mass Na and A cube. Now rho is given as 4. The effective obviously is the stuff I'm looking for. Molar mass of FeO 56 plus 16 is going to be 72. Avogadro number to be used is 6 into 10 to the power 23. And yet again, when it comes to the edge length, it's good that it's given in angstrom, else I would have converted it to angstrom. 5 into 10 to the power minus 8 and whole cube of this. Now again, if you do it properly, somebody would want to give me the right answer. Yes, please. What's the answer to this question? Yes, please. The calculation could be a little steep here.
6.
I got a different value.
फिर 4 आया.
मेरा भी 4 ही आ रहा है. Yet again, it's up to you to figure out how to manage the calculation part. The question at hand is simple as a clux, and yet again, Z effective 4 would mean it's an FCC, and we're going to move on. That's I hope you're understanding me. Seven is an interesting problem. I'll come to what makes 7 peculiarly interesting, but before that, I'll want you all to have a good look and a proper attempt of the question.
तो इसका आंसर मैच नहीं होगा.
Now, this is the peculiarity of this problem. You know what makes this question particularly important? Is none of the options are right. You'll have to get the right answer because none of these are correct. X at all the corners, at every alternate corner. Now, naturally, by alternate corner, I mean 50%. Whenever it says alternate, I believe half of them are taken up. And if they're present at every alternate corner, I would believe the ratio is 1/3 of the total spaces. I believe it's taking up 6 ka 1/3, 1/3 of, I think I'm doing it all right. Please correct me if you find a mistake somewhere. Now this is x 1.5, I reckon. Y, and that's 1. So this could be written as x 1.5 y, or it could be written as x3 y2. So this has to be the right answer, and that makes this problem, of particular interest. X3 y2. We want to move on. I think I'm being understood. Next one. Grunts, Ritisa, Costa. I hope this is
20.
readable again. Yes, please. What's the answer?
22.
22, and I think it's taking a bit of calculation.
Yes.
Not sure, but I don't think it's very calculation friendly. So I'll give you the formal solution. The density being 6, I'll write it as the molar mass. The molar mass has to be calculated. Z effective is going to be 2 for BCC. Naturally, I'm looking for M. Avogadro number is 6 into 10 to the power 23 if nothing is given. And, A cube is going to be 3 into 10 to the power minus 8 whole cube. I'm basically solving rho is equal to the effective into atomic weight or mass of 1 mole of atoms upon Avogadro number and A cube. So what do you get as M from here? Somebody would want to help me. What is M that you get? You can use the calculator and tell me what is the molecular weight that you get from here.
— 48.6.
38.6.
48.6.
Is it written properly?
So not 38, 48.
48. All right. 48.6. So again, you know, number of moles will be weight upon molecular weight, and number of atoms which I'm looking for, number of atoms which I'm looking for is going to be number of moles into Avogadro number again. So this is going to take a bit of calculation. Eventually, as Ritvisa says, 22 will be the closest value. 22 is the answer. So tough one on calculation part. So we'll want to move on. And the phone going to find several questions of this kind. 4 out of 1 or 5 out of 1 is a problem of this kind. Metal M, FCC, edge length, density, Avogadro number, need to find atomic mass. Here again, you know, I have to do a bit of calculation. Rho is equal to Z effective into M upon Avogadro number and A cube. This is exactly what I'm looking for. Rho is given as 9.03. Sorry. 9.03. The effective for FCC would be 4. Avogadro number, I'll go by the value given. And there has to be a way of solving these questions as well, I'm sure. And, you know, this is in angstrom centimeter cube given pretty clearly. Yet again, I had to do a bit of calculation. 86.97 is something which I got. And 87 is the closest integer value. $87 is the closest integer value. We want to move on. Question 10.
D.
Now, this is a nice. Yes, please.
Option D.
Option D. Now, this is a nice little problem. It's a nice little problem. And not very calculation intense. D indeed is the right answer. D indeed is the right answer. And this time, density being 5, BCC that being 2, I need to find the M. Avogadro number is 6 into 10 to the power 23. And 200 picometer is 2 angstrom. I repeat, you know, I'll always want to convert picometer to angstrom because it gives me the liberty of taking it as 10 to the power minus 8 centimeter. And, you know, cube of this would cancel 10 to the power 23 to a large extent. What is it that you get as M?
Well,
So if M is 12, what I need is 300 by 12, and that's going to be 25 moles. D indeed is the right answer. So Babu,
Yes, sir.
attempt হয়েছে?
ऐसा पूरा attempt नहीं हुआ sir.
ঠিক আছে, যদি বুঝতে পারছো, keep responding. Same to you, Grant. 11, and we'll want to move on. So here you have a CCP lattice, and I guess I have told you in the video and right now in this particular class as well. Every time it's a FCC, every time it's a CCP or a HCP. A CCP or HCP, and you'll have the liberty of taking it as FCC. It's naturally Z effective 4. The density is 7.62. Z effective 4. The molar mass of this complex. There's again a calculation to be carried out. Now, the edge length of 0.4518 nanometers. 1 nanometer is 10 angstrom. So I'll write it as 4.518 angstrom. And this is again a hell lot of a calculation. This is again a lot of calculation, and I got it as
100.
106. 106 is the right answer, but again, you have to figure out how to manage such questions, and otherwise do it at the end of solving the ones which are less calculation intense. And we move on. Question 12.
Nine zero seven
9076 is indeed the right answer. 9076 is indeed the right answer. So you want to start conventionally. You will want to start conventionally, like rho calculated with face-centered 4 into copper 63.54 upon Na 6.022 into 10 to the power 23, and A cube is 3.596. So is there a method by which you could do it without a calculator? Which is a, please tell me. I think I've used a calculator, and I don't think this is coming out of
Sir,
naturally. This is so much of calculation. So God help the mindset of somebody who framed a question of this kind in the JEE mains, but you and I need to live with this. 9076, and we move on. We move on. Question 30. Coordination number of an atom in body-centered cubic. Coordination number of an atom in body-centered cubic.
8.
Now, ye bhi na, at the next opportunity, I'm going to explain for other type of cubic crystals. Simple cubic के लिए, simple cubic के लिए, simple cubic के लिए ये 8 होता है. Simple cubic के लिए ये 6 होता है. Body centered cubic के लिए ये 8 होता है. और face centered cubic के लिए ये 12 होता है. ये naturally 6 और 8 समझना आसान है. 6 और 8 समझना आसान है. 6 और 8 में when you are talking about a simple cubic cell, I'm naturally going to meet you at least one or a few times before the JEE Advanced. That is for sure. Simple cubic, what you can do is, you can take any corner as like the origin of x, y, and z axis. And if this is positive x, and if this is positive y, and say this is the positive z, at positive x, y, and z, 1, 2, 3, 4, 5, and 6, you'll have 6 particles around every particle. Body-centered cubic में, what you can do is, you can certainly take the particle at the body to be the reference particle, and the 8 corners around it would prove 8. FCC 12 is again not very difficult to visualize, but the numbers are something which you'll want to be at the back of your mind. 8 in this case. I'll actually spend a little time in the live club and would love to explain a few more things. 14.
Option C.
So you're getting the molecular weight as 50?
Yes, sir.
You sure about it?
The right thing.
I might want to perform a double check because I got a D for this. I could be wrong as well. So the density being 6.17 is equal to Z effective into molecular mass, which is my concern, upon Avogadro number and A cube. Z effective तो उसका 2 ही होगा ना. एक बार वापस क्रॉस चेक कर लो. CA. एक बार इसको क्रॉस चेक कर लो. मॉलिक्यूलर वेट क्या आ रहा है आप एक बार देख लो.
सर 50 आ रहे.
50 पक्का.
हाँ सर.
I could be wrong. In that case, it's 4 NA only. See, Calcutta, we're going to move on. So you might find it very monotonous, but my job was, to present all questions which have come in the real JEE mains, to also give you an idea about how frequently this topic is going to feature in the real exam. Almost in every session, you have at least one or more questions from solid state. And although it's no longer a part of JEE mains, it was a very, very common question in JEE mains in the past. So it forms a cubic unit cell with edge length 405. If its density is 2.7, you have to find the radius of the element is approximately, obviously they want me to find Z first and then relate R with Z.
Sir 143 आया.
143 is the right answer. Naturally, the density part is 2.7 into 10 to the power 3. Which is equal to Z effective, that has to be calculated. The molar mass is 2.7 into 10 to the power minus 2 upon Avogadro number is 6 into 10 to the power 23. And A cube. Now, this is a challenge in the sense everything is in MKS unit, SI unit here. So 405 picometer, even if I take as 4.05 angstrom, would be like 4.05 into 10 to the power minus 10 meter. So this time, it's not going to be 10 to the power minus 8. It's going to be 10 to the power minus 10 and whole cube of this. And I wonder, although 2.7 and 2.7 will cancel out, ये मेरे को लगता है 4 ही आएगा. This is my gut feeling.
हाँ
4
सर
into 4 into 4. This will be like 64 into 6 will be around 400, and it will even out to be a multiple of 4 only. And if that is true, with effective radii 4, I'll conclude it's FCC. And for FCC, I'll believe 4R is equal to root 2A, and R will be equal to root 2 times of 405 picometer. Now, I'll just want root 2 into 405 to be calculated. 1.414 into 405. Again, a bit of calculation. And this will be like 143. 143 is what you said?
Yes sir.
143 is what you said? Yes, we can move on. यहाँ पर मैं 4 से डिवाइड करना नहीं लिखा हुआ है. So this will be like by 4 because 4 are basically. Question 16.
Option D.
16 is a problem, which is more like an ideal problem where a bit of calculation and a little bit of approximation and density could be found out. Density in this case is going to be the effective with FCC is 4 into 63.55 is the value which is given. Avogadro number is 6 into 10 to the power 23, and A cube is X cube. So, this is within reach. I believe. X cube into 10 to the power minus 24 naturally, because that's X in angstrom. So this is within reach. I know it's going to be a multiple of 400 kind of. Yes or no? I'll go with the closest value of 400, which is 422. I think I'm being understood. Moving on. I hope I'm being understood. Moving on. Question 17. Metal with FCC has its edge length given. Tell me what's the answer?
D.
Yes, please.
Sir, option D.
Bigger than Delhi.
Yes.
And you know what needs to be understood in this case is the closest approach between two atoms. The closest approach between two atoms is always going to be twice the radii. You know, when we talk about two atoms, you know, naturally identical, two atoms naturally identical with the same radii. When you talk about the closest approach, we're basically talking about the internuclear distance. So the closest distance, the closest approach between two atoms will be r plus r, which is 2r. In the case of a face-centered cubic, 4r is equal to root 2a. So naturally 2r would be root 2a by 2, which is a by 2. We'll want to move on. Question 18. Sodium crystallizes in a BCC. Edge length is 4.29. I'm sure you would have done it.
Option C.
Very good. Option C, indeed it is option C. The moment they tell you body center cubic, you'll go to write 4r is equal to root 3a. And again, these are calculations within reach. Root 3 of 4.29 upon 4. You know, root 3 is 1.73, this is 1 point something, so you'll want to go with the closest value. It's not like you do exact calculation. You know, I hope I'm being understood. 1.86 angstrom is the right answer. So this is again very doable. Move on to question 19.
Sir, option
Again, I like questions of this. Yes, please.
Option D.
Again, D is the right answer. Granth,
Yes.
you want to solve all of this at the next opportunity. Right now, I hope you're relating to this solution.
Yes.
A कॉर्नर पे है और B फेस सेंटर पे है. तो A सारा कॉर्नर पे रहता है तो B फेस सेंटर पर रहता है तो A भी 3 रहता है. That's a simple pay. ठीक है. You know A भी 3 होता है because it's A 8 into 1 by 8 and B 6 into half, which is ABC. That's the routine case. In this case, one atom is missing. So if one atom is missing, 8 corners would be usual stuff A1, and out of 6, there are only 5 at the face centers. So this will give me A B5 by 2, which could obviously be written as A to B5. D is the right answer. There is a proximity to these questions in the real exam. I've always spoken about the particles in one video and the voids in the second video. So maybe in the problem solving order, again, the second set of questions I give you will involve voids as well. We move on. 20. Which is incorrect?
B.
Yes, please.
C.
C as in Calcutta, I believe.
Yes.
HCP or CCP is nothing but SCC. So naturally, you have 74% filled and 26% vacant. So there's not 32%, it's 26% for CCP as well as SCP. दोनों के लिए 26% ही होता है. This is true, this is true, this is true, this is false, and I want the false one, which is C Calcutta. HCP है ये. HCP, CCP, both are SCC. Coordination number 12 is understood. BCC 8 is right. 21.
C.
BCC, 2R is given. You have to find A. 2R is equal to 1.73 angstrom. That's given. That's what is meant by nearest approach. You have to find edge length. Now in a BCC, naturally you know 4r is equal to root 3a. I hope I'm being understood. बच्चे लोग हाँ बोलो. So if it is 2 picometer, if it's 2 angstrom, it could be very well written as C board linearity, sir.
Sir.
21C Calcutta looks good. 21C Calcutta looks good. 22.
B.
So these are like routine problems. Free space is naturally 100 minus packing fraction. So in CCP, which is SCC, packing fraction of CCP or HCP is going to be 74%. So the space empty is 26%. And for a body-centered cubic, I would have derived it to be 68%. So empty space is 32%. For simple cubic, naturally this was 52%. Have these numbers at hand. मैं ना वीडियो में एक छोटा सा गलती कर दिया हूँ, इसको मैं 68 था 64 लिख दिया हूँ, तो वो थोड़ा सा चेक कर लेना. I might have done some stupid mistake in the video which I shared with you. We'll want to correct the same. 23.
Option B.
23 again looks like a nice little problem. The total volume heat transfer is the FCC, in FCC, I told you the effective is going to be 4. So it's going to be 4 times the effective volume of a cube for sphere and sorting, which is 4 by 3 pi r cube. So this is 16 by 3 pi r cube. B boli na, Aditya sir?
Sir.
Fine. And we arrive at the last problem of this particular set. Sodium and magnesium crystallizing in BCC and FCC. Number of sodium and magnesium metals present is something like ending on a sweet note.
B.
Z effective BCC is 2. Z effective FCC is 4 D Delhi. So here we are done with the first set of questions on solid state. I don't think any question was bothering you too much. I will want to see you tomorrow with another problem session on solid state, because higher secondary is on Tuesday. One more session on solid state, and I'll be able to talk about the voids as well. Maybe the basic structure of NaCl, cesium chloride. Go through all these structures, see the video, go through the notes, let me know if you were out. And I'm going to share another set of questions on solid state. Till then, stay happy, stay healthy. See you then. Take care. Bye bye. Thanks for attending the class. Bye bye.
Bye.